Hello, everyone. I hope you are well. Do let me know if you can hear me because I'm trying a slightly new setup today. So let me know if you can actually hear me in the comments. If you can't, I'll have to go back to plan B. I hope you are all well. We are closing in. The next place we're going to be going is J277, but there's nothing to worry about at all.
It'll all be absolutely fine.
Right. So we are going to. You can hear me. That is Rahan, dear man. How are you? Thank you so much for being here. It is a joy. Right, defensive design, and this is something that we did today in here. Who's T? Hello T. You're new. Let me introduce. Where's T? There's T. T underscore. Catchy name. Catchy name. Um,
Thank you for coming.
this is my new voice toy. I hope you like it. Yes. So here we are. Defensive design. This is what the plan is today. I'm going to start off by looking. A few students said to me, Can we have another look at the data types?" And here's T Tennessee. Hello Tennessee. Thanks for coming. So this is. I can see that slightly off with my camera. Hang on a second. Let me get this sorted out. Oh, and get rid of that bit there. No, wrong way. There we are. Otherwise, the complete mystery of green screen is entirely ruined. So there we go. Let's get that sorted out. Right. So we're talking. I'll run through really quickly some stuff on data fundamentals and getting the. Let's try that, and then we'll look at defensive design. So it should be quite straightforward. Some of this you've heard before, and some of this was around the past papers we did before. So let's have a look now at a bit of a quiz time and see if you can remember these. Any idea? You'll miss that jingle one day. So who have we got in here? We have Bear. What a good man. Thanks for coming. I know Deason is very distracting, isn't he? We've got I am Deason Parrick. No, there's only one Deason who's here. Hi, Deason. We've got Paul Burner. It's that handsome man again. Thank you for being here. We've got T underscore still here. Hello, Hayden. How are you doing? You're already answering questions. You're saying 5. Which program in the line calls the procedure? T for Tennessee says 5. Deason says 5. Rahan says a lot of 5s. Laura, hi, how are you? No idea at all. And Rusty, thanks for coming, says Billy. Okay, so not one of the options, but hey, let's see what the answer is. Well done, Isha. Thanks for being here, dear boy. So the answer is 5. That is absolutely spot on. Right, let's push on. Let's do one more. Look at the program below. What would the value of new num be if the user entered the value 10? So I recommend you have a look at some of these examples that I've sent you, and I'll give you some more past papers to have a look at as well, and try to develop the patience to work these things through. So T is saying 12, which is pretty quick. Hayden saying Youssef, which I don't think is the answer. Pablo, we've got Laura's coming with 12. We've got Pablo's coming with 12. And we've got T, who has just abusing everyone else, which I think is perfectly reasonable, and Decent coming in with 12. Shall we see what the answer is? It is 12. That is outstanding. All right. And we had, hi, Manor. How are you? We had Manor with 12. We had Hayden with 12. We had Paul Burnham with 12. We had Ishak with 12. You are all absolutely astonishingly good. And we had Rahan with an individual answer of 12 plus 0, which is 12. So still absolutely correct. Right, let's push on. What's it all about? Well, today I'm going to cover sort of these two sections. And this is the end of 2.2 and the start of 2.3.1, which is defensive design. The sound effects are really loud. Are they? Okay. That's interesting because I turned the sound effects up. So that's what that has done. So is that frightening you? I have to turn those down. I can do that in a sec. I won't frighten you with sound effects for the time being. So it's this bit here I'm going to focus on first at the top, this part up here. I'm not going to spend too much time in SQL because I've done that. And then I'm going to spend the most of the time going through this stuff here, which really is more of a list, but it's an easy one for them to answer in paper 2. And it's paper 2 because you can see the 2 here, right? So this is sort of easy marks for you in paper 2. Right, let's push on and get it done. A 10-minute teach. I changed it from a 5-minute teach because that was just overly optimistic. So I'll jump through this part of it reasonably quickly and start with SQL, just to remind you that SQL involves three statements: select, from, and where. So if you get an SQL question, look back at your notes because it really is money for old rope marks on SQL. It's so easy to do. So in the example here, I've got select age and address, and these are the attributes or the rows in your Excel spreadsheet in your table. So the rows running along the top, he says, running along there. Pick which one of those need to be included in the query, which is a question you're writing for a database. Um, they also that is very kind of you, Rahan. That is absolutely awesome. Um, yeah, I've got great hopes for you guys in this exam. I really do. Okay, back to this. So select the rows, which is fundamentally what this bit here. So if we're thinking about an Excel spreadsheet or a table, which is the same thing, first of all, select the rows you want to be included in the table. The other thing they do is put the star here, which means select all the attributes, sorry, not the rows, the columns, okay? Then, this one's so easy, which table are you taking it from? So in the question, it'll say, this is exams table. So you just write from exams. Easy peasy. And then you put in the condition. So where the surname starts with this, or where something equals this, or where something is bigger than that or less than that. So all that programming stuff you've done before, right? So that will give you Mary's age, address from the table student. So that one, SQL, go back and make sure you're happy with these three things. And if you write select, from, and where, and the from is the table, the select are the columns, and the where is the condition. You can get some marks. You can get a couple of marks, even if you don't really know how to complete it. Procedures. Only thing to say about procedures are that you've got procedures and you've got functions. So then you've got this idea of parameters, and these are the numbers, the variables, the quantities that you're going to pass into a subroutine. The difference is procedures. This is interesting. So we're going for the international pick on decent time, um, and this would work quite well, which is select decent from students where annoying equals true. And that, of course, wouldn't select decent because he is amazing and does very good geese impressions, as I've learned to my cost. Right, so procedures. Procedures do not return values to the main program. They love this. What's the difference between a function and a procedure? And there we go. This one, procedures don't return a value to the main program, whereas functions do. Functions, and there we go, they return a value to the main program. And they run a sequence of instructions to give you a repeatable piece of code. And they accept parameters from the main questions. The parameters go in here. And if you've got more than one parameter, let me highlight that again. That's where your parameters go. And if you're taking in two bits of information, you separate the parameters with a comma. All right, boom, that's it. That's your functions. Nice and easy. So go back and make sure you're happy with that anatomy of the function. You start off by writing the word function, then you give it a name, then you state the parameters over here. Let's get over there. Then you write your code, and then you write return, and whatever you're saving it into, that's the name of the variable you're saving it into. And then you write end function. That's it. That's all you've got to do. Okay, so that's your function done and dusted. File handling. Go away and learn these really simple snippets of code. Okay, you've got open for opening or closing a file. You've got read, which is basically to copy, and you've got write, which is to write down, and then you've got save at the end as well. Okay, and you've got create, which is new file. So have a look at those in the specification because it's about half a page of code, and if you know that for the file handling, and I reckon that'll be in there because they didn't do it last time. Okay, which brings us on to the next thing we're going to do today, which is producing robust programs. So this is all about writing programs that are difficult to hack and that don't tend to break. And you can simply learn this as a list of things that you have to do. So they can start by asking you, what is the purpose of defensive design? And the purpose is to ensure that programs run correctly by avoiding errors, misuse, and program crashing. So errors might be in Windows when you get the blue screen of death. Errors might be misuse, that the program's used for a purpose that it wasn't intended, or the program can crash. Okay, And in fact, to be honest with you, these two are quite similar. Okay, these the errors. It might just generate errors, or it might cause the program to crash. So they're similar but slightly different. So that's why you've got this defensive design. So when you're writing a program and you're writing your code, you do it to make sure that these things don't happen. That's why you're doing it. Okay. All right. The first one is validation. So, validation, you need to use that word and learn that word and understand what it means. And we were doing a past paper today, which more or less said name a couple of things you can do to make to make programs robust. And you had to write validation and then explain what validation was. So, data validation can take about 3 or 4 different forms. Okay, so validation in itself, it helps the programmer ensure that the program will not produce an error because of the input. So validation is looking at the input. So for example, you're writing a piece of code where you're going to take in a username and a password, for example. Okay. So let's look at the first one, which is a range check. So these are the different examples you've got. This one here is a range check. Say, for example, you are taking in someone's age. You wouldn't want to have the number being 0 because we don't do that in this country. They do in certain cultures. They have age 0. Um, and also, you wouldn't want a negative number. You can't be minus 10 years old. Equally, you'd have a cutoff at somewhere around about 120. I don't know how old the oldest person ever to live is, but do you need to know the? No, I don't think you do actually. I'll double check that. That's a good question. I don't think you do, but these are examples of them. I will. That's a good question actually. I'll go back and remind me, and we'll have a look at the spec together at the end. But I don't think you do. I think I may have hung on to this from 276. But I'll give you some example. You know, the previous iteration of the spec. Then you've got a length check. So range check is between 2 numbers. The length check, let's get rid of that. The length check is that it's got to be a specific number of characters. So to avoid an SQL injection, and hopefully that's pinging up all of the work we did on the scary SQL house, where I think I had someone strapped to a bed upstairs. Probably I should have thought of a better example. That's pretty horror filmy. But where you're only going to accept a password that's a certain number of characters. So that's a length check. Or a phone number, for example, which is 11 characters. Yeah, 11 characters. So if you're taking in a phone number, you could say it has to be exactly 11 characters, or else you know that it isn't a phone number. Okay, a presence check. So that means that you can't leave it blank. So you know when you're filling out a web form to get something free, and you press submit, and it says you haven't filled out this field. That's a presence check. That something something has to be there. Then we've got the format check. Think about date. The date needs to be in a particular format, and we do it in a different way to the Americans. They do month, date, year. We do date, month, year. The Japanese have got it sorted out. They do year, month, date, which makes a lot more sense. And then you've got a type check. In other words, is it an integer? Is it a float? Is it a real? So you've got to enter data in a certain way. So those are the different sorts of validation checks that you can put into your programming, okay? And you can therefore be more likely to only take in the sort of data that you actually want. All right, so there are 2 ways of anticipating misuse, which is the next part of that. Yeah, if len string, yeah, this is good actually. I should look at the comments and try and read some of these. This is absolutely spot on, okay? There we go. So that's exactly what you do. You're only going to take in a certain string length. Now, they're not going to make you write a piece of code to do this. You just need to understand the principles that there is a way of sanitizing data. There is a way of checking the sort of data that you can bring into a system, okay? So misuse, and you've got input sanitization. So just jumping back to here for a second. Hang on a minute. Oh, let's go back to here. Come on. That's good. So this first thing we've looked at is validation, right? So that's the first sort of category that you need to focus on there. So validation, and make sure you know what it means. And I will get back to you at the end whether you need to know the types. I can't remember. Then, after validation, we're going to look at anticipating misuse. And under this category, we've got 2 distinct areas. We've got input sanitization and authentication. Taylor, dear man, how are you? Who have we got here? We've got TabSpark. Hello, TabSpark. We've got Haroon. How are you? Long time no see. And we've got Taylor. Hello, Taylor. Thanks for coming. Right, two ways of anticipating misuse. We've got input sanitization and then we've got authentication. So, input sanitization is checking the data that comes in, and authentication would be checking that a username and password match. So, for example, yeah, try turning up the volume because if I turn it up any more, it'll start to sort of distort at this end. So I don't want to do that. Yeah. Okay. Cool. So you've got input sanitization. This is another way that you can anticipate misuse. Another way that you can produce robust programs is by these two methods: input sanitization and authentication. And we can relax now because Johnny, the bad boy, has joined us. Hi, Johnny. How are you doing? Um, uh, if those are your muscles, that really is quite bad. Um, okay, so again, go away and learn these. Input sanitization is checking that checking the data that's entered and removing any potential data danger, such as SQL. Okay, and then you've got authentication, which is checking the username and passwords match. So, for example, when you set up an account, you set a username and a password, and when you try to re-enter that database or that website, it checks to make sure that they match to allow you in. Again, why would you do it? And this is a good one to learn. It stops unauthorized users. Now, the reason it's got doesn't there is because authentication itself, if someone steals your username and password, it doesn't stop unauthorized users. Two-factor authentication might do that. Okay, maintainability is the next chunk of this. And this is when it comes to writing code. This is the one that you tend to remember, okay? Is that maintainability means that when you've written your code and then you get promoted to another job or you leave and go to another company, that someone who then has to update your code when they bring out a new operating system or want to add features to it, this is what you're taught to do when you write code professionally. So first of all, this notion of writing sub-programs. So you don't just write one massive great block of code, you write sub-programs or modules or modularization as it's called. And you can see how that fits into these ideas of abstraction and decomposition, that you decompose something, that you've made it the simplest version of what it can be. You've broken it down to the smallest level of problem. So using subprograms makes it easier to understand the code because you're looking at less code each time. So looking at 10 lines of code and figuring it out is much easier than looking at sort of 1,500 lines of code and wading your way through it, okay? So using subprograms, Bing, one mark for that. And did I mention to you, this is the other buzz phrase here. And by the way, I've nicked all of this from from mark schemes. So I went through the mark schemes and I did a word frequency check. And these are the words that keep cropping up in mark schemes. And these mark schemes haven't changed for about 20 years, okay? So maintainability ensures that programs can be maintained easily. It could be a mark for you in there explaining what it is. Hi, Ziggy. How you doing? Thanks for coming. So using subprograms does this, easier to understand. Yusuf, dear man, how are you? Thanks for coming. We've got loads in today. How many have we got in? Millions. I'll have to check. Okay, then we've got naming conventions. So that's naming things, giving things sensible names. I'm actually in the wrong place to do that. Here we go. Let's get rid of that. So giving things sensible names, all right? So example, using size instead of S. So if you need to drill down and they go for 4, 6, 8 marks on this, there's loads you can get your teeth into. So you can say what it is, why it's useful, and then give an example, okay? So that's a naming convention, giving things sensible names. No spaces between names, like house num, for example, because spaces between names is really bad coding. Then you've got indentation, and we know what indentation is. That's starting the next line slightly further in. And if you're using an IDE, which is an integrated development environment, it will do it automatically for you when you start to use constructs like selection and iteration, okay? And you've got comments, and comments help explain the different parts of the code, and they're useful for people to understand the code. So there's quite a lot here, but bear in mind, this is paper 2. And I know that most of you find the thought of paper 2 slightly more daunting. This is actually easy marks to get because it's just a list of stuff you can learn. So my recommendation is go back through this and make sure that you've got a list of the different ways in which you can make code robust and you can make code maintainable. Okay, the last part of this is testing. So you should obviously test your program as you go along and test your program at the end. So sometimes they ask, "Hello, Rukshan, how are you? Thanks for coming." I'm curious to see how many we've got in today. See if I can figure this out. 'Cause we had 30 odd last week. No, okay, my thing's decided to break. Right, plan is this. You've got testing is important because it checks if the program behaves as it should, if it's got any errors, if the program meets user requirements, and if there are any security issues. I want to pick up this one here because the rest of it's pretty obvious, but this one here might need a bit of unpacking. So when you write a program, you don't just sit down and think, "I'll write a piece of code." Not if you want to get paid for it anyway. You have your client who, hello Max. I hope you're going to sit this exam now and get a 9 for me. So you've got a customer who said, "I'd like you to write a piece of code that does this," and you will sit with that customer and you'll come up with a list of user requirements, the stuff that it has to do. And then does your program actually do what it's supposed to do? So you'd write a test plan where you would say, I've been doing this with year 13 IT students who are doing some game design at the moment. Does the character move left when you use the left arrow? Does the character move right when you use the right arrow? Does the character jump when you press the space bar? You know, that sort of classic arcade game you might play like Donkey Kong or something like Flappy Bird where you're literally just pressing one button repeatedly, okay? So also checks for any security issues. Okay, next. It checks. You've got two types of test. Iterative is during development, and then you've got final or terminal testing, which happens at the end. So that's why you have testing. Again, it's just a list of reasons as to why you have testing and why you do it. All right, this, again, easy peasy. So let's think about a program that's supposed to accept in a month of the year. So it says enter the month in which you were born. So you could run a couple of tests on this. So you've got normal test data, boundary test data, and invalid erroneous test data. So if you're going to input, if you want to accept an input from a month from 1 to 12, 1 being January, 12 being December, what would be normal test data for that?
Does anybody know?
I've got a whole range of exciting voices. We've also got this one. Does anyone? Oh, that's exactly the same. Does anyone know? This is my station announcement one. Yes, correct. Anything between 1 and 12 is the correct answer.
What would be boundary test data? The boundary up here. I don't know what would have happened to me to speak like this.
Now let's go back to there. That was quite scary. What would boundary test data, if we're doing from 1 to 12, what would boundary be? Yeah, Johnny, I've got a new little thingy here which makes my voice do quite bizarre things. That was a depressed robot. What would, yes, I was young again, very, very briefly, although
I'm not sure I ever spoke exactly like that.
that's actually was like Alvin and the Chipmunks. I'm still sort of damaged from having watched that so many times with my kids. It's just wrong. What would be if you're accepting in from 1 to 12? We said that normal test data would be 1, 2, 3, 4, would be within that range, right? 1 to 12. What would boundary data be? Boundary would be 1 and 12. Thank you, T, for coming to the rescue here. And can I put yours on there? Yes. So T has said boundary would be the numbers 1 and the number 12. Correct, because it's at the boundary. And then the invalid data would be 0 or minus 10 would be 13. So they will sometimes ask you to describe which is boundary, which is normal, and which is invalid. Again, a really nice, easy question. Okay? We've got Rukshan, we've got who's that? Rehan, we've got Ali Hussein. Hello. Is Taha in the house? I didn't see Taha. I was here. And we've got Bilal. Well, the party can really get started now. We are there. Yusuf not agreeing with Taha is just wrong on every level. Okay, let's get into quiz time. So let's have a bit of a quiz. What do we think about this one? What other defensive design practice helps programmers do this? There we go. I won't play any applause because I think it'll frighten you. It's too loud. What do we think? Ah, you didn't even spell your own name right. Harsh, but fair. What do we think? What other defensive design practice helps programmers do this? Ooh, hello. Decent has come in with commenting. Shall we see what Decent has done? The answer is the use of subprograms. Commenting actually isn't in there. Well, commenting was there. Oh, Decent. Honestly. Yes. So that's the answer of subprograms. Subprograms or modules, right? Modularization, which I struggle to say, or subprograms. How are we doing time-wise? 56. I don't intend taking you much beyond 7 o'clock. So look at this. Look at line 4 of the pseudocode. This code is formatted using what? Because it's part of an if statement. What one word completes the sentence? Do we think? Ooh, Rusty has gone from indentation. Let's have a look here. Personally, Ziggy is quite rude. Rishi Sinak, I see. Indentation we've got here. We've got a full stop. We've got indentation. We've got indentation. We've got indentation. Well, you all sound very convinced. The answer is indentation. I will risk frightening you all. There we go. That's scary now. Well. Sorry, life sucks. What about this one? Indentation and so, and comments. Yes, indentation and Pablo. No, Pablo would not be the correct answer for this. So authenticating users, regularly updating programs, and writing code that's easy to read are all ways of using... No, not that. Are all ways of using... No, not that. There we go. Are all ways of using what design? Yes, you actually had the answer before I figured out what to do. So the first to the buzzer was Rahan, outstanding, and Ishak, and Jelly, and Paul Burner, and Decent, and Rahan got a second W, and defensive, and Decent, you got it wrong. Everyone's too slow. Okay, good. I love the abuse. It's what makes it worthwhile. Ooh, here we go. Here's a new one. Question 4. Look at the table. Which test has flagged up an error in the program that needs to be investigated? Hayden, you were right. Some might say 6 months after the event, but you were right. Got some quick answers here. Jelly's come back with 3. Ziggy's come back with 3. Yusuf has said 1 Pablo. Pablo is figuring a lot in these. Rahan said 3. Ali Hussein said 3. Hello, Ali. Rusty said 3. 3. Let's have a look. Let's have a look and see what the answer is. Boom, boom, boom. The answer is 3. Now, Mr. Moller's educakes come in handy. Yes. The educakes, I don't know why it's cake. It's very irritating because I like cake, but as you can probably tell. But the educakes are useful. So go back and have a go at those. I'm hoping Madrid beat City 3-1. That's my answer. Okay, Hayden, it's a gamble. 1-0. Yeah. What I don't want is City to walk away with it. I want them to suffer. I've memorised most of Moller's educakes. Good. Which are the most useful of Mr. Moller's educakes, do you reckon, guys? Which are the ones you've done that you really liked? Yusuf, they're both bad. Bilal loves cake as well. Good man. 10-12 Madrid. Crumbs, that'd be something. That would be something good. The next answer, authentication. Right, let's go on to the next one then. 31. I've got a couple more of these to do. Question 5. Look at the pseudocode. What type of error would occur in this program? Now, don't forget, they love these errors. They love to ask you questions about these errors. So what do we think the answer is? No, you're not going to fail paper 2. Just make sure, Jelly, none of that talk. You're not going to fail paper 2. You've just got to go about it in a deliberate way because they're only going to be asking you for 3 different things. Can you work out how to do selection? Can you work out how to do account control and a condition controlled loop and figure out which one to use? get some marks for all of these. Right, you're all screaming logic at me. Laura, very quick, logic. Hey, logic, logic. Logic, logic. Rahan, you missed twice donut. Okay. I'm glad you two abuse each other online as much as you do in my lesson. The answer is logic. So we've got logic and we've got syntax, all right? So that is looking good. Question 6. You've written a program that asks the user to input their age. Now you want to check that the right message is displayed if the user enters an unrealistic number. What type of test data should you use? Sanuka is in the house. Hello, dear man. I hope you are well. You've missed my exciting new feature, which is
The ability to use silly voices.
right. What do we think is the answer to this one? You are slightly late. So Rukshan's come back with invalid. Sanuka leave. Not very friendly. No, you're on time. Slightly early. Good. Let's see a bit of sarcasm there. Error in invalid. Okay, should we have a look and see what it is? Stand by. The answer is invalid data, which means that. Oh, hello, Dom. Invalid, which I think was the first right one. No, it wasn't. Rukshan was the superstar. And then we had Dom with invalid. And then we had Laura with invalid. And then we had a few of you just abusing each other. And Jelly said, oh, Rusty said invalid. Jelly said invalid. And Ali said invalid. Okay. I think we are almost there. I think that is it. All right. Next time, I'm not sure that is what I'm going to do next time. So I want to have a look and see if I can find J277 here. Hang on 2 seconds, because I want to answer a question that you guys had asked me. If only my mouse would actually do what it was supposed to do. Right, let's see if I can get this over to here. Are you going to play the ball? Are you going to play ball? Are you going to do what I want? Oh, I need to come out of full screen, that's why. Hang on a second. This has to work. I've got it. Have I got it here? I have. Right, let's try full screen on Google and have a look. Now, I'm sure you've all done this already, but you really do need to look at the specification. I mean, if you don't do it now, J277, just eat, no. Which I have not spelled correctly. J277 specification. There we go. This is the guy. So let's have a look and see if you need to know the different types of. Let's have a look down here, the different types of validation and so on. Dun, 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 dun. 2.3 is what we're looking at. Let's have a look. 2.3, 2.3, 2.3. 2.2, 2.23, 2.3. Okay. Let's make this bigger. Can we do that? What's this annoying sidebar? Go away. There we go. That's better. And let's make it bigger so you can see it. There we go. Right. So let's have a look at this. I'm looking at defensive design. Understanding the issues a programmer should consider. That's fine. Understand how to deal with invalid data in a program, yes. Authentication to confirm the identity of the user. Practical experience of designing input validation and simple authentication, e.g. username and password. Understanding why commenting is useful. So no, you don't need to understand that. So this is always quite handy because over here it tends to tell you sometimes what you do need to know and sometimes what you don't need to know. So they're going to focus on this bit here, which is subprograms, naming conventions, indentation, and commenting. So for each of those, make sure you know what it is and why you'd use it. Knowing input validation, so you don't need to know the different types. It doesn't say they're going to ask you on that. How to deal with invalid data, no. And then we've got anticipating misuse and authentication, which are all the headings that I did on... Let's have a look. Laura's asked a good question here. Do we get predicted papers, or are they basically all the same questions, just worded differently each year? Yeah, so it's kind of a bit of both. They tend to vary their because the specification's too big for them to include everything in detail in it. So it tends to there will nearly always be a question on every No is the answer we came to for that. I think that was in J276. The different types of ones you don't need. Just need to know the purpose of it. But still, knowing one or two is quite helpful. But that's not in the spec. So to answer your question, Laura, they probably will ask something about every part of the specification. So you know the first bit. Let's zoom back up to here. The first bit. Come on, machine. Let's try doing this. The first bit is. Have I just gone the wrong way? I have. Yeah, let's go to here. So the first bit that they will always open with something on system architecture. They always do, and they will stick in a difficult question there about the different registers, and to make sure you understand. There we go. Here we are. So they will kick off with, if you've got a definition of the fetch, decode, execute cycle, and you can describe it, you'll get a mark. Then they will want you to demonstrate that you understand what these different components are for. And don't forget, I mean, they're all components, but what the role of these is, what they do, and then the different registers, there'll probably be a 3, 4, 5, 6 marker on different registers, okay? And then they're going to look at and then we've got the registers down here actually, the MAR, MDR. So there will be a question on the registers, and this one here actually is talking about this. So from this section here, you'll need to know that the registers are high speed, low capacity memory. That's often that's sort of inside the CPU itself, and then knowing what they do down here. Okay, but what you don't need to know, see here, you don't need to know the details about how it passes between register to register. I have put a quite decent video on the YouTube channel about the CPU. Ignore the first one because it's a bit waffly, but I did 2 after that, and they will be quite good if you're struggling with that. Okay, CPU performance. How do these affect CPU performance? Clock speed. So clock speed is how many FDE, fetch, decode, execute cycles per second, and then you've got cache size and knowing what cache holds, and then the number of cores. So they often do a question, and they'll say if there's a 2.6 single core computer and a 1.2 quad core computer, which is faster, and so you've got to do the math, and obviously a quad core has got 4 cores. So you multiply it by 4. So that will always be in there. They do like a question on embedded systems, so things end up bringing up things like microwaves and fridges. RAM and ROM, that'll be in there, always is. Virtual memory we've done to death, and that's when you're using RAM, this bit down here. And that's when the RAM is full, so using your hard drive as RAM. Different types of storage. This you can just go away and learn. They often do big mark questions on this one too, all right? Then these, make sure you're happy. This is so easy because it's only this bit that's different. A bit, a nibble, a byte, and then it's just thousands, all the way down. They will ask you, they want to make sure you know that everything that a computer does has to be in binary. Why? Because a computer is it's circuit boards, and circuit boards only recognize 2 states, on and off, which can be reflected with ones and zeros. I'm going on beyond the time now, so I won't do that because I know you're all super busy. Data storage, you guys are good at all of the binary and the hex stuff. Go back and remind yourself how to do that. Easy peasy. Characters, ASCII versus Unicode. The fact that you can represent more characters in Unicode. What a character set is. Metadata, they like a question on that. I reckon there's something on that. And color depth. So we're now into characters, images, and sound. Make sure you're happy with your definitions of bit rate, sample rate, color depth, all that sort of stuff, so you know what they do. Compression, lossy, lossless, and the fact that you could use lossy on images and video, but you wouldn't use it on text. Different networks, LANs, WANs, network hardware, all that sort of stuff in there. Always big marks on that, and they do like a question on domain name servers, and they like a question on those 2 topologies. And just make sure that you can draw a diagram of each, and you can talk about the advantages. Here we go. Look at this bit over here. The advantages and disadvantages of this. So looking through this is actually a really useful thing for you to sort of tick off what you can and can't do. This is what I was looking at. IP and MAC addressing, one can change, one can't. The MAC can't. These protocols, they absolutely will ask you something on that, and that tends to be a high tariff question. So make sure you're happy about those. And all you've got to know is what they actually do. Okay, you don't need to understand any great level of detail on it. In my class, certainly you've done this to death. Okay, the malware, the spooky house of horrors we talked about. Prevention methods, we've done that to death as well. Operating system, people often leave this one out because it looks so bleeding obvious, but make sure that you can actually describe the purpose of an operating system and these different things that it does, what it provides, user interface, memory management, and so on, okay? Utility software, and that comes down to what it is and the fact you've got 3 flavors that you need to know: encryption, plain text, ciphertext to render it unusable if it's intercepted, defragmentation, and data compression. People always muck this one up, okay? And then we've got this, the Big 8 marker. Make sure you've got a list of things you can talk about for that, okay? Again, I've got a video on YouTube for that, so have a look back at that. And then we're into paper 2. So paper 1, I know that's a sort of whirlwind tour, but paper 1 is actually something that you guys can still, even at this late stage, go and get sorted out. Right, has anyone got any burning questions before I go and watch the football? I can see you've just been horrible to each other, so that's fine. Is there anything else that you want to ask me? Oh, hello, T's got a question. Will we get asked file size calculations? Will we get asked file size calculations? Will we get asked file size calculations? Yes, I think you will. And if I'm doing a question predictor, I think that they are going to, let me find it on here somewhere. This is something that was new in the specification 2 years ago when they first did this, and they haven't included it so far. Yeah, over here. I predict there is going to be one of these, right? So that they're going to make you do some simple maths, that you've got to calculate the file size of a sound file, an image file, and a text file. If you actually look at how you get to that calculations, cheers, Rahan, take care. If you look at how you get to those calculations, it's actually pretty straightforward. So they're going to combine, let's try again. They're going to take this and they're going to combine it with this here. So they might give you a sound file size in bits, and they might ask you to do the calculation and then change it into megabytes or kilobytes or whatever, okay? So a sound file, sample rate, so how many times the sample's taken a second, and make sure the a second gets you that mark, multiplied by the duration of the file in seconds, and then multiply by the bit depth. So you've got 3 things there: image file, color depth, image height, and image width, so the actual physical size of the image plus the color depth of it, and text files, the bits per character and the number of characters. So I reckon they will do that for you. Has anyone got any other questions? That was a good question. I predict there will be a 4 to 6 marker on this. So make sure that you can do that, because that's a nice, easy one for them to mark. All right, guys, no problem. You are absolutely welcome. Have a lovely evening. I think 3-1 for Real Madrid. That's my prediction. And I will see you guys. Hello, Dennis. How are you? Gosh, I can't get away from you. So I'll see you all tomorrow. Take care. Have fun. A couple more of these left, and I'll do them in between paper 1, focusing on paper 2. If you're paranoid about paper 2, I will give you some extra help with that. Guys, take care. Be good, and I'll see you in school tomorrow. Cheerio. Bye-bye.